Okay, so this week we're going to cover Unit 2, which entails network attacks. So we'll start with talking about network sniffing, which is what we're going to be doing today for the lab. Some of you are quite familiar with it, maybe. Some of you are new to it, and that's okay. So the sniffer that we're going to be using today is going to be Wireshark, but let's talk a little bit about packet sniffing. This is mostly what you see in kind of like a gray area. Sniffing is not active as far as when you're performing recon. Um, a lot of the sniffing can be done as soon as you can get attached to the network. So the easiest area of the network that you often see is going to be the wireless part of the network. So packet sniffing is a way for us to really determine, number one, network activity, right? The packet is going to tell us the type of payload or data that's being transmitted across the network. We can also take a look at the devices that are communicating in that network. So that's going to help you understand what kind of appliances and systems that the target has, right? If you're looking from an ethical hacking standpoint, and then the type of data that's being sent across the network. So that means that we need to have a really good understanding of TCP/IP, right? And looking at the type of protocols that's being used on the devices. So for example, we know that web server uses HTTP, right? HTTPS. And then if you have other services like DNS, port number is also important. But the data packets is going to tell us a lot more information than just protocol, right? IP addresses or MAC addresses. The payload is also gonna give us some details information like passwords. So there are attacks that can be performed on the wireless side where we would be able to look at the packets and see information about credential that's being used, right? So in the forensic part of cybersecurity, it's also important to look at the network and using sniffing. And then you can also take a capture and then go back and replay the capture, right? You don't have to monitor the live network traffic, but you can record the live network into a file and then go back and evaluate that actual file. So now a lot of the questions come up. Is it legal for me to perform sniffing, right? Just remember that there's some gray area in what you do with the type of information that you discover. So packet sniffing in general is legal if you use it for, number one, maintain and managing our network environment. If you have a purpose in what you do and not using that packet sniffing information for malicious reason, it is legal. But if you're using that information in an illegal way, then it becomes illegal, right? So there's some gray area that we have to really think about. So now it is illegal if you access the data packets in an unauthorized way. So if you're trying to get a password and you're using that password to access the system without permission, it becomes illegal. So the purpose of the information and the purpose of how you use that information is going to make it legal or illegal. Okay? So make sure that we understand that from an ethical hacking standpoint. Now, you can do hardware packet sniffing, which you would use a physical device to be able to do that. But most often that you're going to see in IT management, in security, in network administration, you use software packet sniffing like Wireshark, right? Or NetDiscover in Linux, which is what we're going to be exposed to today. And that's going to be very popular because we do have a lot of open source. So let's go through and answer the questions. And I forgot to share screen, so let me do that. Okay, So for the first question, it asks you, why is packet sniffing important in pen testing and network administration? We know that tools like Wireshark, which is a packet sniffer, we can use that to really look at our network vulnerabilities, the weaknesses in our network environment. Why are there weaknesses? Because protocols have weaknesses, right? And the protocols were developed from a long time ago and we're still using it. Any type of traffic flow, you would see that when you opening doors, there's potential that someone can get in. But the services and the protocol that also bring weaknesses into our environment. And then assessing your network is going to tell you how healthy or well performing or underperforming is your network environment. So the performance is going to be displayed through your network traffic. So remember that availability is an area that we need to address in security. So therefore, we need to assess network vulnerability to make sure that we have, right, a secure network environment and a well-performing network environment. So you want your network to be available 99.99999%. Right now, they're saying there's 7 nines. It used to be 5 nines. So the highest as you can achieve to make sure that your network is available for the users and the system that needs to communicate. And then in the case that you're troubleshooting or even in when we're doing investigation, like malware investigation, right? Attack investigation, we would capture our traffic being sent across and be able to see the issues or looking at how we can solve or find information. So that's important. And for 2, it asks you describe when is packet scanning legal or illegal. Packet scanning is legal for network administration, as we talked about, or securing network purposes. So if you're using the information to maybe improve your security solutions, like for example, I see that there are many open ports being available for the same type of service. That's gonna allow me to go back and change my configuration. That is legal. Packet scanning is illegal when it is used to access unauthorized packets and data. So because the payload in the packets can give us information such as passwords, right? So what we want to make sure that we use it in a legal manner. Any question? And this is Unit 2 assignments. Okay. For those of you who just got started. So what we'll do is we will take a look at one of many packet sniffer. And you can look at the website wireshark.org as I put the link there. You can visit the website and on the website it will tell you what kind of packet sniffer it is, right? Wireshark is a software. It is open source. It's available to us. And we don't have to pay for it. Wireshark is a packet sniffer. It's also known as a protocol analyzer, and we can use this software to capture our network traffic. It is a very common tool that you see. Now, if you're using Linux, you can run Wireshark on Kali or Ubuntu. You can install this on Windows environment. I think it's also available in Mac OS. You can also use another variation of something that's similar, which is your packet sniffer. You can use something like T-Shark, which is also common in Linux environment. So what you would see is in T Sharp, you would have more terminal based output compared to Wireshark, where you would have UI, where you would have graphic display. So that way, and it will color code it for you, which is nice, right? We'll do that for the lab today. And so why do we spend time talking about this, right? So this is one of the crucial activity in recon, scanning after you have started gathering information, which is what we talked about before. After we build the intelligence for our target, what you're gonna start doing is you're gonna start scanning. And the first scanner that you often use would be your packet sniffer or network scanner. Any question? Okay. So with that, we would come back to what we would see as sniffing attack, right? When you hear the term sniffing attack, it basically is someone or an attacker use packet sniffer to capture traffic, right? Activity on your network. And through that, they're able to obtain confidential or encrypted data or unencrypted data to be able to find more information, right? To gather the details that they need potentially to allow them to have access or obtain certain type of data for malicious purposes. So malicious packet sniffing here, it talks about how you can use ARP, which is address resolution protocol. Do you guys remember ARP? What ARP does? And which appliance have ARP too? Right? So I know I covered this in my 27 class on Monday, right? But if you simply do an ARP-A, and I'm gonna jog your memory, right, real quick for those of us. So if we do CMD for command prompt, right, which is, I'm using Windows now, right? If you do ARP-A, this is gonna give you an ARP table, which is address resolution protocol. And on the table, you would see that you would have IP that's correlated with MAC, which is the physical address, right? And we know through networking knowledge, right? If this information is new to you, that's okay, right? Address resolution protocol is used to be able to say that this system on the network using the IP address also has an address that's physical, that's engraved onto the network adapter that could be wireless or the NIC. The switch maintain an ARP table, right? Devices that allows you to interconnect within the network are switches. And switches have that table to be able to associate. So that way, the next time that you're trying to communicate with another system, let's say a server, right, on the 5th floor, it has that already information so it can resolve that connection very quickly. Now, if you're looking at how the information is given to you here, it's saying that they can conduct further attack with ARP. Why? They can do ARP poisoning, like they can modify your ARP table in a certain system. They can also do DNS spoofing. DNS mostly is in charge of what? Domain name resolution, right? Or it's able to associate an IP address to a domain. And then, so if they're able to spoof that, right, they can redirect the traffic into their own server or their own domain. So there are many different reasons or intention in why they're capturing this information from your network. Or they might be able to look at your data, your payload in the packets and possibly doing code or SQL injection. I think we're pretty good at closing out the SQL injection in a lot of like the application for the databases on the web. We're able to integrate like rules and making sure that we develop in a secure way. But you have to know that, ultimately attacker is gonna find ways to navigate to certain area that you are not looking at, you're not protecting, right? So we want to make sure that we cover all ends. Now, just like what we talked about in recon or intelligence gathering, there's passive and there's active sniffing. So when you're doing passive sniffing, right, you would monitor the traffic through the hub and it is pretty stealth. It's quiet, okay? And it's really difficult to detect. So from an attacker standpoint, they can do this without being monitored closely, okay? Now, active sniffing is when if you're using switch network and if you're looking at, certain destination for the received data, they would need to be able to, or they want to do this so that way maybe they can do packet stuffing or they can inject additional traffic. So why would I want to do that, right? Maybe I want to overload a certain type of security appliance so that way it's not responding or sending out the alarm when I'm entering the building. It's similar. So my analogy for this is, let's say that someone is trying to rob a bank. They don't just come in when it's all quiet and the surveillance is on them, right? What's going to happen is they are going to create some kind of activity that's going to distract everybody so that way it's not going to, the camera or the people who are watching them is not focused on them. And similarly, you're going to have tactics that are like that, where you would have packets that are false packets that are being added to the traffic. And we call that sometimes is traffic stuffing, right? To be able to disperse the traffic and also occupying your appliances. And so that way they can go undetected. So you do see some active sniffing in some targeted network area. So next, we will go through. And describe the difference. So I wanted to summarize this, and you can pull that from the notes. The difference between active and passive packet sniffing. Passive packet sniffing captures network traffic that the device is connected to. So you're on your computer. If you're running Wireshark, your computer is connected to that network, right? Or let's say that I'm on my laptop, I'm connecting to a public Wi-Fi. I'm capturing the traffic from that wireless network through the hub, which is the wireless router. Passive sniffing is difficult to detect. There are ways that you can detect if they're sniffing out, and we'll talk a little bit about that later on today. But active packet sniffing requires overcoming network security barriers like your firewall and adding traffic to the network. So it's not just that they're looking at our network, but they are adding more traffic into our network. And in order to do that, they have to override the firewalls or intrusion detection system or intrusion prevention system, your IDS or IPS. Active sniffing is very visible in the network, right, for the detection. So that means that they have to make sure that the IDS, the IPS, or any kind of security appliance is not tracking or seeing that. So that means that for the active packet sniffing activities, this has to be thoroughly planned. That they have to already kind of map out what kind of security appliances you have, right? Or have an understanding of it. How to overcome those in order to perform active packet sniffing. So if you're just running a Wireshark session on your laptop in a wireless environment, that's passive, right? But remember, right, we don't go do that to all the networks because sometimes, that can come back and saying, what are you using that information for? Why do you need to gather this information from our network, right? So we gotta be careful. Any question? Yes. Yeah, so you have to override or overcome or disable them because they will send off alarms. It's specifically adding faults or additional traffic. So, and normally you don't generate traffic externally like that, right? You would only allow traffic for the system that's permitted inside the network environment. So intrusion detection system would automatically sounds off or, you know, prevention system it would then prevent. So let's think of it this way. It's kind of like you have a camera in your home and that camera is going to detect all your family members. But if you have you know, if someone places a camera in your home, you're not going to allow that, right? You don't want people to look at your home. And if they start entering your home and they would have more people entering your home, that's adding more network traffic, then that becomes not a malicious activity. So that means that your alarm system should sound off, or your camera system should be able to detect that they are a stranger and they are also looking at you, right? So active packet sniffing is not just looking at your network, but it's overcoming your network security and adding more traffic into your network environment. And that's considered like a sniffing attack, right? But sniffing attack can entail other things that's involved DNS and ARP, like what we talked about before. All right, so let's go through the scenario and see if you can let's look at how these cases would be related to various type of attacks. So number one, a hacker is connected to a wireless access point, your AP, and performs a scan on the network. And we talked about this before, right? This is a passive wireless sniffing attack. It's still considered an attack because it's not authorized. So if you're connecting to a wireless network and you run a Wireshark application to scan that network, that is a passive wireless sniffing attack. B, a hacker is scanning the user's network web connection and activities in the interactive online forms to obtain the private data and credential information. So they are scanning, right, the network connectivity for the web, and then they're looking at the packets of all your activity, like the forms that you fill out. Maybe I upload a file to that form. Maybe I'm submitting my tax, right? And through that, they're able to get the payload information and obtain private data or credential. So this is considered an active browser history and JavaScript sniffing attack. And so how do I know it's JavaScript? Well, the keywords that you see here that tells you that it would be a form of JavaScript or web, because it's web-based. And interactive online forms, if you ever work with web development, interactive online forms is written or created through JavaScript, right? You have to use JavaScript to create those forms. So now how can they reestablish your connection? It's through browser history. So in this type of attack, it's a little bit more personal and it's really targeted to that particular user session. So what you see is you do have browser-based attack and then sniffing attack. And we'll come back to browser and web-based attack in a later chapter. C, a hacker performs a network scan and get the user session ID on an e-commerce website that uses the ID to access authorized data such as shipping addresses. And this is very common with HTTPS, right? With encrypted session. So when we log in to our bank account or an e-commerce website, we can perform certain activity. And through that, right, it needs to create a session. So it gives you a session ID. So this is considered a session hijacking.
D, a hacker sets up a rogue DHCP server by flooding the real one with multiple requests for IP addresses to occupy legitimate DHCP server, then uses packet sniffer to monitor the network activity. So DHCP is used to provide the user with IP addresses on the network, right? So in order to attack that network, they can also put up a fake DHCP server. Now, if you are a really good security administrator, it should seize that and take it out offline right away, block it, right? So now how do they connect this server to an open port is questionable. So you have to take a look at how did they get, because the only way that it can broadcast IP address is through an open port. That means a switch port that's available and they can connect. So that means that they might physically connect a cable to a switch port, and also logically, if that switch port is available, then they're able to broadcast IP addresses. Because the DHCP works this way. When your computer starts, it's gonna reach out to the server saying, hey, give me an IP address. Okay. The DHCP server is gonna say, okay, looking at the scope, and it's gonna say, okay, here's an IP address, right? So there's communication back and forth, and that means that there's gotta be a physical connection and a logical connection for those two systems to talk. So when they're putting up a rogue DHCP server, that means that there has to be an open port that's available for that rogue DHCP server, right? And then that service is available because, of course, we allow the DHCP server for our own environment. So when they're flooding it, that means that it's just doing broadcast storm. It's just gonna flood. Now, when you send out false IP addresses, everybody becomes disconnected. Their connection becomes interrupted, right? And sometimes this can be accident. My students, sometimes when they run the DHCP server, they accidentally broadcast IP address, because if you don't configure it and contain it, it sends it out to the rest of the network, and that becomes a flood. Now, with the flooding, if you control the switches properly, you're able to contain that, because any form of broadcast on the switch should be set, and if your switch is smart enough, it's gonna stop it at the switch level instead of sending it out to all the branches, right? Because the switch's job is to send that out to the sub area, the segment of your network. So now, if once the flooding happens, they take down the real DHCP server. So that means that they have access to it somehow or able to disrupt it, and then use packet sniffer to connect to the network activity. A similar tactic to an evil twin, but not quite, because in an evil twin, if we put up a false router, right, we're able to kick off the real router and then be able to monitor the network traffic. So a little bit similar in tactic, and this is considered the DHCP snooping and sniffing. So a little bit of work going into that, and from this case, you have to think about, like, if I'm the security person, how do I stop this from happening, right? So logically, you're gonna have to work from how it's connected all the way to how it's configured, and then how it's taking down your DHCP server. And then E, a hacker intercepts data packets and sends false messages to the network, redirecting traffic away from the user's IP address to fake website and trick the user to enter the login credential. So that's man in the middle, right? Your MITM. It's also ARP sniffing and DNS poisoning. How do I know it's DNS poisoning, ARP sniffing, and all of that? They're keywords in the case that you see. DNS poisoning is when they're redirected, right? Whenever that you see redirection, usually it's involved DNS spoofing, DNS poisoning. So that's one attack, right? And then they're intercepting data packets, so that tells you that it's man in the middle, okay? So if I'm intervening, so let's say if I am the server and you are the client, you're communicating with me, the way that they can capture the data is they have to be in the middle they have to eavesdrop and be in the middle. And in order to do that, they have to spoof, okay? So Then redirection, we talked about that, and then also redirection away from the user IP address. So that means it has to be an ARP sniffing. Okay, because remember, ARP does what? Associates IP address to the MAC. So if I wanted to move the traffic away from the actual real IP, I have to be able to sniff out ARP to know which one has a real IP with the physical address, right? So with that, I probably have to do a spoof in order for that to work if I'm the attacker. Understand? So when you see a situation like this, what you do is you would dissect it into sections. Looking at the type of attack that's happening from a security professional standpoint, focus on how you address each area individually and then combine them. Because what's going to happen is there's no one solution to fix all of this at once. You're going to have to go, right, either sequential or step by step in order to get through this problem. Okay, so here, some more information and details about all of the attack that we talked about, right? Your ARP sniffing, we talked about MAC and IP, DHCP sniffing. So here it says that a hacker can gain what from packet sniffing, right? They can send malware into the network. They can gather or get important files or do ransomware. They can access accounts, credential information. And so how do I defend against sniffing attack? Number one, patching. Update your software to reduce exploitation, like 0-day. Making sure that you have endpoint detection, okay, and response. So you can use EDR or SIEM or the SIEM. You need to perform breach and attack simulation. So pen testing is going to help you understand how easy it is to get into your system or how difficult it is to get into your system and networks. And then ultimately, authentication and access is a key area. So multi-factor authentication and beef up your access level. And, this individually requires, implementation and deployment could take time and resource. Okay, we're good with this section, right? I'll move to the next page. 6. When performing reconnaissance of the network, what is the step after the information has been collected to determine the IP address range? So last week we talked about this, right? We talked about gathering information from a passive technique, gathering information from an active technique. But after we gather the information, and then what, right? Once you have IP address range, then you need to determine which are the active systems. So active systems are the systems that are connecting, that's responding, that's working, right? So let me ask you this. So how can I find out what system is active? What can I do? Is there a tool that I can use? Is there a command that I can use to find out? So let's say that I have an IP address range, a group of IP addresses from a certain part of the network. And I can say, okay, maybe this is HQ, right? Corporate office, headquarters, here's the IP address range. What can I do with that IP address range to determine which systems are active? Start with a P and with a G. Ping. Now they can block ping, right? We know that ICMP might not be available all the time. So the best thing to do is you can do HP ping tool, but we can
visually ping. If you ping and it's blocked, then you know that that port, that service is off. Some administrator may block that. But many systems require ICMP to be available so that way it would be able to receive requests, right? So we can ping. You can ping a range of IP address at once, right? In Linux, you can do that. In Windows, you can do that. So that's gonna tell you the type of active system. You can also do what? You can use command line hosts, right? For sure. So we have to think about, so having an answer like this is very broad. And when you go do it, you're like, okay, I remember she told me to look for active system. So you think about, oh, what kind of tools do I know to be able to do that, right? So you have to know, like, you know, if something happens to your car, right? If you are out of gas, fill gas, right? Same thing. Identify your active system, ping, right? And there are other tools that you can do that to identify active system, but that's one of the more simpler tool that we know. Okay, so 7, fill in the blank. A blank is a program that's designed to find and take advantage of security flaws or vulnerability in an application or system, typically for malicious purpose, and that's called an exploit. So when we're looking at exploitation kit, that just means that many tools is combined into a suite that's used, right, to take advantage of flaws on application or system. And so what you see with Metasploit is that, right? And then there's other exploitation kit that's for their own purposes, that's designed for their own purposes. Okay, so where do I find this information on the note, right? After all of these, I wanted to mention this because if you were going for Pen Test Plus or CEH, they emphasize the phases and the steps, right? To me, in my opinion, every textbook, every, you know, website, every reference that you see have their own sets of steps. But when you do this in real life, it is just a logical movement. It's kind of like waking up in the morning and brushing your teeth and getting coffee, right? So collect initial information, gather intelligence first thing. Then you are going to get in the recon process. You need to get to network information. Remember we talked about IP ranges, define active machines or identify that, right? We talked about pinging. And then after that, you need to find access point and ports. Now, that can be obtained initially if you're doing active intelligence gathering, like using Nmap. It's already giving you the ports for some of the systems. But you might be able to use other tools to be able to do that as well. And then your fingerprint operating system, you have to sometimes for web servers and things like that, you need to banner grab, right? We saw a little bit of this in the lab last time, so you need to find the OS. Why? Because OS might have vulnerabilities. They do, right? And we will be able to take a look at those. And then looking at the ports that you found and how the services are using those ports, like port 80 for HTTP, right? HTTPS 443, right? DNS and so on. And then ultimately mapping out the network. There are tools to map out the network. Nmap kind of give you how far you are from your target and so on. But sometimes you would have to manually kind of map out the network. So if you are doing blind testing as a pen tester, that means that they give you nothing about their network. You have to do all of this manually or finding the information on your own. And you have a limited of time to do that, right? So your engagement would entail this. And then as much information and flaws as you find, that goes onto your report, and that's how you get paid. So ultimately, the goal are these things, okay? Get IP addresses, host name, open port certificates, server banners, gateway, and routers. So if I were you, if you want to do this, have a checklist, right? So what you have is
you're gonna have a scope of work. Let's say that they would say, okay, you need to assess our DMZ systems, right? Our web servers, database, and so on. When you start planning, you need to make sure that you have a list of things that you need to go through. And when you find them, you go through and you take notes of that information, and then you would move to the next thing, right? Can I find credential and email addresses? Can I find employee information? And then going into security, right? What kind of security measures there would be, hardware, software, firmware, operating system information, and so on. So the list is long, okay? Any question? Okay. So we can use exploitation toolkit, but from a security perspective, what you would have is, how can you locate these exploits? Where can you find information for the recent vulnerability, right? Where do we start, right? So some of this information is very similar to what I lecture in CIS41A. CIS41A focuses a lot more on how we can analyze this stuff, right? But in this class, we're going to focus on how we can pen test and obtain this information. So there are databases that you can go into to be able to find exploits for software, right? For hardware from various vendors like Microsoft. Okay. And then you would have various common vulnerability exposure databases from vendors as well. Microsoft does that as well, right? And security fixes or implementation for the CVE. Sometimes there's no fix. Sometimes there is, right? And so it's always a race between who can discover that vulnerability and fix that first, right? So if you're on the red team, then, that can be used for non-good intention. If you're on blue team, right, that can be used for protection and defense mechanism, right? So we can reduce the vulnerability, we would reduce the risk. So keep in mind that we can use ExploitDB, the databases from the vendors, and CVE's listings or databases from the vendor. So this is why what you see is a lot of IT manager, they prefer to have one brand, right? Like I would have all Dell computers, Dell servers, Dell everything, right? Why? Because it streamlined the administration and the management, things like that, and also this area as well. But sometimes you would have an environment that must be diverse, right? Because your users are going to have their own devices. They bring their laptop to work or their mobile devices to work. And then you also have to support some of the diversity in your system. Back in the day, I was told that diversity is a no-no in IT, right? But that's not the reality. The reality, what you see now is just there's so many options in technologies. And we use technology to its best. So if you're using one type of things, then you might not be having the best capability for your environment, for your network. So, and then sometime that technology would go out. It becomes legacy. They no longer produce those type of systems. Then you have to upgrade to a different brand. So, and with that, we would have a group of databases that we have to keep up with. Okay. All right, I'm gonna swing back to the notes now, sorry. So some of the recon tools, I think you saw Nmap last time, a little bit of Burp Suite. We will work on Metasploit. We're gonna see Wireshark today. We'll look at Beef later. Cobalt Strike. There are many others, so these are some of the common ones that you see. And then here is the exploit information. So by definition, exploit is a program or a set of code that's really designed to take advantage of the vulnerability in application or system, right? And we talked about how threat is like that. So it is a form of threat, right? Because a threat, it takes advantage of, or it capitalizes on the vulnerability, right, for malicious intention. So this is what you see with exploit. And then the databases, as I mentioned, so if you look at the notes, I actually put down the link for you to look at. So if you know, we did a little bit of search on Nmap last week when we were doing the passive intelligence gathering, and we saw that there's Rapid7. So Rapid7 is involved in a lot of different areas of like security and technology for security. So what you see is they do have vulnerability in exploit DB. There are pen test tools, vulnerability and exploits DB. So you can go to the websites to be able to find that. There are really, really great resources for you to utilize for the field these days, right? And then for CVEs, these are the common ones. So you got Mitre. I'm sure you have heard of it by this time, right? Or if you've taken another class, there might be information about Mitre. So I put some of the links, including NIST, right, and CVE.org, CISA. So these are really good resources for you to go look at, right? We don't have to start from scratch. People built it for us already. We would go, and then you can share information and resources on there as well. All right, next question is about Packet Storm. So Packet Storm security, this is going to allow you to have current and historical security tools and advisory, and you can visit packetstormsecurity.com. It is, you know, put together by a group of people, and they publish security and tools information for educational and testing purposes, right? So you can find some resources there as well. Which brings us to question 9. It asks you, what type of website provides current and historical computer security tools, exploits, and security advisory? Packet Storm Security is one of those websites. But you can also go to Mitre and be able to find that information as well. And then for question 10, it says identify the types of network vulnerabilities based on the given descriptions. A, the Windows Transport Protocol often used for file sharing, printer sharing, and access remote services with port 139. So my advice for you is know your ports and know your port well, memorize them. Because a lot of your scan results is going to give you port information, like a port number, and you would need to know what port that is, what kind of services is used on that port, right? Like what I had put in the information there, and then you need to research that, okay? So for A, that will be your SMB, server message block. This protocol is used for file sharing, printer sharing, access remote services with port 139. So when you're zooming and you're dropping the files into your Zoom chat, that is also SMB on Windows system. Okay. A client server model architecture using separate control and data connection for file sharing between the client and the server. This is a file transfer protocol, and this is the non-secure one. Anyone remember the port number for FTP? Very good, 21. You need to remember port number for Security Plus and Network Plus as well, right? And then 22 is for SSH or SFTP. That's right. So know your ports. C, mail server application used to send, receive, and relay outgoing mail between servers and receivers, or senders and receivers through port 25. So when you see port 25, the first thing that comes to mind will be your SMTP, Simple Mail Transport Protocol. That's how it routes outgoing mail, like when you click send. And then for Windows system that use Wins, which is a legacy older technology that's still being implemented in our operating system for Windows nowadays, this is how it's going to use to translate your computer name to an IP address, right? Your host name to an IP address. This is known as your net BIOS and the name service. So the older protocol, if you recall, that will be NetBEUI, right? When I started the field, that was what protocol was used. So it's pretty dated. Right. Question. Okay. So all of that, right, you can see more description of what NetBIOS summary is. And then there's also link local multicast name resolution, your LLMNR. This is for DNS packet for IPv4 and 6 hosts. This is a newer integration to work with both version of the IP addresses for DNS. So in Linux, you would use the command system for LLMR, MNR, I should say. This started since Windows Vista, which is probably way before your time. Server message block is here. It also used port 445 as well, but the common one that you see is 139. So I put a little bit of note like your internal blue exploits, WannaCry ransomware, which is somewhat kind of more recent. You know, these are the historical exploit and incident. It capitalized on SMB vulnerabilities. So you've seen big incidents or big threats that utilize this particular type of protocol. And then your SNMP, Simple Network Management Protocol. This allow us to use the application layer to monitor and managing network devices like this. Wake on LAN, how are you going to turn on all the computer in your network at once? Or, you know, to be able to determine which system is on, which system is off, or deploying images by connecting them all on network switches. So instead of installing OS on one computer, I can broadcast it from my main switch so that way the software would be installed onto the computer itself. So SNMP is a critical protocol in network administration. So what you see is it's used, and there are currently 3 versions. Now, you see network appliances, sometimes they come with this capability. They come with the protocol that allows, like, for example, like I buy a layer 4 switch and I want to integrate that with my network environment. Some switches come with SNMP capability, and you would have different versions. So version 1 have port security and the password is in clear text, so don't use version 1, right? You should be at version 3 currently, which is way better because you do have encryption and other things with it. But anyway. And then for SMTP, for the mail transfer protocol, you got direct exploit. You know, you do see phishing attacks and spam attacks through SMTP. And it's still happening, right? And then for file transfer protocol, you would do this for the non-sensitive data. but it's definitely not secure, and it allows anonymous authentication. That means that I don't really need authentication. I just click anonymous, right? And then to be able to send my data. So upload and download, and everything could be clear text. So you want to use SFTP or SSH. Okay. So more information about network-based attacks. Okay. So for 11, what type of attacks entails fake information being entered into the cache? And we know that cache is used for temporary storage of the domain name server, resulting in DNS query producing an incorrect reply, sending users to the wrong website. This is a way that they can redirect traffic as well, and this is called DNS poisoning. DNS poisoning, why is that, right? They get access into the temp storage and the cache information of the domain name. So in the DNS query, right, when the system is trying to connect, the client is trying to connect to the DNS and it's submitting the query, right, which domain this is. So instead of, let's say, for example, google.com 8.8.8.8, it would say, something else.com for that particular IP address. So what they do is they poison the cache, they modify the cache information, and that's how they redirect the traffic for DNS. And then you also have another form of DNS attack. Says what method of attacks would consist of adjusting the server configuration and direct the user to a malicious site. So for the redirection, right, you can also find it as being called DNS server hijacking. So instead of sending it to a legitimate domain, they would send it to a server, and that looks like the legitimate domain, and that's how they can gather your credential, right? So for example, I would put up a fake website of a bank, redirect you to that website. So whenever that you're trying to reach your bank and log in, right, you would get to the website, and then when you log in and nothing happens, I have your credential, right? That's how I fish out your credential. So, and this is done through phishing attacks as well. So sometimes you would see a lot of these type of attacks would couple with other attacks in order to be successful. Question? Sure. So in a DNS attack, it's a fake website that they're logging in. So they would set up a fake website that looks real, right? Redirect you to that website, and then when you log in, you type in your real credential, and then you might get an error or some kind of message, right? And most users, they're not aware of that. So it is a form of hijacking, right? Where you already got redirected, you provide them with your real credential, but you really don't log into your real account because your real account's not there. It's at the other website, right? But they have your real credential now, and that's how they're able to take your real credential and impersonate you, right? So you guys hear about that cryptocurrency attack with North Korea that happened in the last day? So $1.5 billion were taken, right? But when I was reading through the articles, I wanted to find out, like, how did they get this, right? And they couldn't, and it was happening for so long, and they couldn't catch them. So first approach was social engineering. They got the staff to give them sensitive information, the person who did it, and the attacker is from North Korea. They said he's sponsored by the government, whatnot. But he got the staff at the exchange to give him information on the inside. That's how he got into the system. And then to not be able to track the transfer of the cryptocurrency, he was doing a laundering mechanism so that way it cannot be tracked. So there was 410 or 460,000 Ethereum coins that were taken, and that was equivalent to $1.5 billion, right? And then now, even with the drop in cryptocurrency, it's still about 1 billion, let's say, and still up today, they're not able to track it. So the FBI is investigating it. Read the article, it's really interesting. I think it's just started hitting the news like about a day ago. So when you get a chance this weekend, look at it. Okay, 13. For attackers, what are the purposes of DNS poisoning? And that should be an S. One, to steal data, because data is assets. Two, to infect system with malware. Three, halt security updates, because security updates close out their access or potentially stop them from doing what they're doing. And then lastly, to censor web access. So those are some of the main purposes that you see for DNS poisoning. Any questions? Let me move 13 down a little. So while you're still working on that, we can look at the next question. For 14, it asks you, in Windows, what type of attacks target NT-LAN manager authentication system? And this should be pass the hash or PTH. As some of you are studying for Security Plus, or you have studied in past Security Plus, right? You probably have seen this before. So NT-LAN manager, NTLM authentication system, this allows you to put in your credential and log into your Windows. And this is a legacy. Now, when you're doing a brute force attack, you are also capitalizing on NTLM. Like if you're using Cain and Abel or some, John the Ripper, some form of attack type of tools to be able to get access with credential through authentication system. In a Windows environment, likely that you're going to use NTLM vulnerability to do that. So this uses pass the hash, and Cain and Abel does that, right? It's able to capture the hash where your password is stored, and that's how the password can be cracked easily. So the longer the password, right? Supposedly our password is encrypted, and Microsoft is saying that it is harder to breach the password. However, it's just about time and resource, so processing power and the amount of time. So if you don't have any policy like account lockout, brute force can happen. So pass the hash is a form of attack to get your credential in a Windows environment that uses NTLM. For 15, describe the two phases of man in the middle of attack. So how do they do man in the middle of attack? So first thing, they need to intercept the traffic. And in order to intercept the traffic, they have to study the traffic. So likely that you're going to have a sniffing attack before the interception. And so they would intercept the user traffic, making their system be the destination, right? So likely that they would need to spoof. And then with that, they would need to decrypt or decipher the traffic without changing or altering the user or the application. Question? Yes. Say it again. When does what happen? The spoofing? they need to spoof to receive your traffic. So let's say that I'm sending you, you and I communicate, right? You're supposed to receive whatever that I'm sending. And Dre wants to intercept our, whatever I'm sending to you. He has to pretend to be you in order to receive my traffic. Because my data is intended for you. But in order to receive the data, he has to pretend to be you. It's either, yeah, so it has to, they have to do an impersonation. What do you mean to get? You don't need to get into your system, they just need your identity. Either your user account or your system identity, which is your IP addresses, right? And you would see that man in the middle, that sounds like just a one form of attack, but usually it couple or it incorporates other attack within or before. And also you use that for additional attack. So like session hijack, usually go with man in the middle, right? Okay. 16, describe the type of attacks that can be performed in the burst phase of the man in the middle attack. Sometimes you would see replay attack. The replay attack allows you to have data interception or altering the data and forward it to the destination. That is different than a relay attack. The relay attack is when both parties are initiated by the attacker, merely relaying the message between the two parties without manipulating them or even necessarily reading them. So that means that they're on both ends, right? I can be pretending to be her, and I'm also pretending to be a sender, right? So that's a relay. The replay is how the data is intercepted and modified and forwarded. Question? I'll move it up a little bit. Maybe too low can be difficult to see. And then for 17, we will continue with man in the middle attack. Describe the types of attack that can be performed in the second phase of the man in the middle. So after replay and relay happen, right? What are they going to do next? So earlier, you heard Dima asking, when does spoofing happens, right? So you have to do this, and then you move to the second phase, which is HTTPS spoofing and other form of attack. So HTTPS spoofing is a way to send a fake certificate to the victim's browser, because when you're connecting to a certain secure site, right, it requires a certificate. If you don't have that certificate, you don't have access. Okay? So they would use a fake certificate, submit that to the victim's browser, initial connection request to the secure website once it's made. All secure websites use SSL or TLS. So whenever that you visit HTTPS, right, that uses either TLS or SSL, secure socket layer, right, or TLS. So that allows encryption for web. Now to exploit against that, you would see that the attacker uses SSL Beast. Beast stands for Browser Exploit Against SSL TLS. This script allows interception of encrypted cookies sent by the web application, and it can also be used to compromise cipher block chaining for cookies and authentication token this decryption. So SSL Beast is a powerful script. Then you would see SSL hijacking. This is how they can forge authentication keys that are passed between the user and the web application during the TCP handshake. Because when the server serves that, right, there is a TCP handshake because TCP needs acknowledgement to send acknowledgement from the receiver to send. And that would make it a compromised session. So as you can see, these form of attacks, or in many attacks, you have to be well versed with what's happening between the system for a certain type of connection or the communication, right? Even on the web session, how they're attacking is they are utilizing the weakness in each step of the communication, and that's how they're able to get the attack performed. So I'm hoping that after this class, you're gonna see the background on what is happening with each form of attack, right? We will not perform all the attacks, but there are times that we will run tools to simulate a type of attack so you can see on our own system, of course. And then 18, what type of downgrade attack consists of forcing web browsers to rely on old, weak hashing algorithms? This is called sloth, or SLOTH. Security losses from obsolete and truncated transcript hashes. Because on your new web browsers, right, these weak hashing algorithms are no longer implemented. So what we would see is, in order to force your browser to use weak hashing algorithm, they have to do a downgrade attack. We will have a chapter on denial of service attack, but since we're talking about different types of attacks, right, we're gonna bring in denial of service attack. So for 19, it says, what type of denial of service attack occurs when the attacker sends a request to connect to the target server but does not complete the connection through three-way handshake between the client and the server? So that's a SYN flood, right? So as you look at the network traffic today, you're gonna see, if you focus on HTTP, you would see that there is time, right? Whenever that you're visiting a website, first, your system requests the web service to, like, if you type in like google.com, right? You're requesting the service from Google. And in that, there are acknowledgement or three-way handshake that happens. So in order to perform a denial of service attack by sending requests to the target server, so let's say that I want to perform an attack by using the request, that's a SYN, right? SYN stands for synchronization. So when you do a flood with synchronization, right, through the three-way handshake, that's a SYN flood attack. And not all denial of service attack falls into this area, and we'll touch more on this. But when you look at the network traffic today, you know, if you take a look closer to web connection you would see. And then there's acknowledgement once that's served, right, from the web server. So how does an attacker bypass network access control on the network? This is known as the NAC. In order to bypass it, they need to spoof an IP or a MAC, because network access control look at system addresses, right? So basically, we would allow a certain type of systems by IP or MAC addresses, similar to what you see with some firewall. So in order to bypass it, they have to spoof an allowable or the IP that the network access control system would not reject, or a MAC address in that matter. So a lot of the security appliances, right, what you see is in the design, it's using address, right, port connection, protocols, or sometimes we would look at like activity and behavior. So that's usually what we have to work with. So we can filter based on that, we can block based on that, we can allow based on what's set in those rules for those systems, right? And that's all she wrote for today. I'm going to stop recording, and then we're going to take a 10-minute break. We'll finish earlier than what I suspected, and then we'll come back and start the lab.